3 minutes past 6, and I would like to officially start our webinar, which is going to be the second one for the year. My name is Getty Shinda, and I'm the Young Professionals Program Coordinator. And I will be facilitating today's meeting. As Sechaba has shared the meeting agenda, I hope you can all see it. We have 4 items today. The first one being the welcome and a short presentation on networking given by me. And then we will move on to our guest speaker for today, who is definitely not a stranger in the groundwater space around SADC region. His name is Steve Kumwenda. He will be our guest speaker for today. And he will be presenting to us on understanding groundwater resources and infrastructure through borehole forensic. Then he will be followed by a young professional. His name is Silas David, and he will be presenting to us today on his work on evaluation of interpolation methods for mapping potential hydrogen for Windhoek municipal boreholes. Last but not least will be Sechaba, who will present to you the communication plan for the Young Professionals Program. Then we have Q&A at the end, where you will have a chance to engage with the presenters that are planned for today. So with that, I'd like to warmly welcome you all to today's webinar. I hope you'll be able to learn from it, and you'll also be able to network and meet hydrogeologists across the region. Thank you very much. So we can move on to my presentation, which will be on networking, which I know it's a very, very challenging and nerve-wracking topic for many people. And I just want to share some tricks and tips on how to improve networking, especially with our upcoming conference that will be in November in Lesotho. So I want all the young professionals to be ready to network at the event. So Sechaba, I'd like you to kindly share the presentation for me. Thank you. I'd also just like a confirmation that you can all hear me.
Yes, I can hear you.
Okay, all right, great. While we are waiting for Sechaba, let me look at the chat. We have, hello YPs, my name is Bongekile Maseko from South Africa. And I see we also have Kevin Peterson, who is the youngest young professional on the team. Welcome, Kevin. All right, I see the presentation is up. Let me get to it. So once again, okay, the presentation was meant for last week, so 12th September, but I know today is the 19th September. So we proceed with the presentation, which is titled Networking at Conferences, Strategies for Young Professionals. So my name is Getty Shinda, like I mentioned, and I'm the program coordinator, and you can reach me at the email below, which is yp@sadc-gmi.org. Next slide. All right, so in this presentation, we will be looking at 6 items. The first one is why networking matters. Then we will look at preparation is key. The third one, engaging with confidence, which is very important. And then leveraging on social media. And then we'll move into networking mistakes to avoid. And the last one, networking is a lifelong skill. All right, next slide. Okay, so why does networking matter? Well, networking is key to career development and growth. It might not look like it's key directly, but indirectly it's key. It is the second point is conferences are high impact environments for making industry connections. So always use the opportunity at conferences to network so that you can create an impact within the industry. And effective networking can lead to mentorship, job opportunities, and collaboration. So when you network, have the end in mind. It shouldn't be, you shouldn't be waiting for an output at that time, but look at it on the long run, how you can look into getting mentorship, look into getting job opportunities, and looking into collaborating. So as we all know, the 6th SADC Groundwater Conference is going to be held in Maseru, Lesotho this year, on the 13th to the 15th of November. I hope you have all managed to register. It's free for young professionals. So I need to see you all networking at the event. Next slide. Before the conference, preparation is key. So you have to understand that networking is something that you plan for. It just doesn't happen naturally. Okay, for some people, maybe it does. But for most of us, we need to prepare for it. So the first tip is to research the event. Know the key sessions, the speakers that are going to be attending, and identify individuals or companies that you want to meet. So already have a target audience. The second one is set clear goals. Define what you want to achieve. Is it learning? Is it mentorship? Or are you looking for job leads? The next one is creating an elevator pitch. It doesn't need to be scary or serious. Just a 2-sentence just prepare a 2-sentence, which is concise, engaging introduction about who you are and what you do. And the last one is bring business cards or your LinkedIn QR code. I know we might not have resources for business cards. So always make sure that you have your LinkedIn app on your phone so that you can just follow the individuals that you want to continue networking with after the event. This way, you already add them to your connections on LinkedIn. And another thing is always make sure that you send them a message when you introduce yourself, just so that they remember when you follow. Next slide. Okay, now that you have prepared for the conference, when you attend the conference, this is how you engage with confidence. So the first one, be approachable. I know some of us don't really like smiling, but smiling helps. So be approachable. And also when engaging, make sure that you maintain eye contact and show a genuine interest in others. An important tip one person once gave me is a handshake tells a lot. So make sure you always give a firm handshake. The second one is conversation. So don't hesitate to introduce yourself to people or groups. Conferences are designed to meeting new people. However, when joining a conversation, always read the body language. If it's open to joining or it's more like a closed meeting or a closed conversation. So reading the body language when joining existing conversation is very important. Ask open-ended questions. So these are questions that are like, for example, what is the biggest challenge you are facing in groundwater management? Just a question that someone can openly answer in any direction. Or for example, how do you see the future of water resources management evolving in the SADC region? Or you can also ask questions that are related to the session or related to the conference. How have you attended this conference before? What has evolved over the years? So these are the type of questions that you come up with when approaching someone to just start a conversation. And you can also ask conversations about the person themselves. Like, how did you get started in this career? That is a good question. Then the person can tell you how they started and how they are progressing so far. The next point is take notes. Jot down memorable conversations to follow up effectively. Because sometimes you think you'll remember everything, but you might forget some key things. So every time you meet someone that you want to remember, make sure you jot down why you want to follow up on them. And the last one is maximizing networking events and breaks. So be strategic, not overwhelming. So practice active listening. So try to always speak less and listen more. Ask engaging questions, and then you listen to the answers. Then you have follow-up questions to what the person is answering. Next slide. Leveraging on social media. This one is very important, especially during the conference. So it's always nice to post. If it's maybe a 3-day conference, you try to post daily, like how was the event? What did you find engaging? Just post on your media, your platform media, LinkedIn, Twitter, Facebook, wherever you feel comfortable posting. Also, usually conferences have hashtags. So always remember to use the hashtag so that your post can be seen by more people that are at the conference as well. And the important one is follow up. So always follow up with those people that you have met and you would want to build a meaningful connection after the conference. Be prepared and respectful of other people's time. Ask for advice, not jobs. So always seek to try to get advice, not directly ask for a job. Follow up professionally, through email, LinkedIn messages to build the relationship further. Next slide. Excuse me. Common networking mistakes. Being overly aggressive. So networking is about building relationships and not pushing for immediate outcomes, like what I mentioned. So it's long-term. Think of it long-term. So just build the relationship. Talking too much about yourself. So the aim is for a balanced conversation. Be as interested in others as they are in you. So let it be more about the person you are engaging than about yourself. So try to listen more to what the person has to say and ask follow-up questions on what they are saying. And then another mistake people make is forgetting to follow up. This is very important because people meet a lot of people at conferences, and following up is what makes you stand out. So the connection is only as valuable as the effort you put in to maintain this connection. Next slide. In conclusion, networking is a lifelong skill. And networking is not just a one-time effort at a conference, but a long life skill, career skill. The more you practice, I can promise you, the better and more natural it becomes. Conferences are perfect opportunities to meet industry professionals and expand your network. So this is the end. I believe this is the last slide. So I hope it was informative for you and you will be in a better position to network at our upcoming conference. Thank you very much. All right. So now I'd like to welcome our guest speaker, who is really not new to anyone. Majority of the people do know him. His name is Stephen Kumwenda, who is a professionally trained groundwater resources and infrastructure technologies development and management expert with a background in rural and urban water sanitation and hygiene programs. He's currently working at Baseflow as a water resource program manager and hydrogeologist. So he will be presenting to us understanding groundwater resources and infrastructure through borehole forensic. Welcome, Steve, and thank you for making time to join us. Yes, Steve, I'm handing over to you. Welcome.
Hello, Getty.
Yes, I can hear you. I can hear you. I can see you. Welcome to the Young Professionals webinar series.
Thank you. I had just an internet disruption. I hope it doesn't continue.
It sounds perfect, so I hope it remains this way. Thank you.
Thank you so much. First of all, let me thank you, Young Professional organizing team, for according me this opportunity to interact with the young professionals in the region. It's a great honor. It's such a great honor. I hope your introduction, you have mentioned a little bit of my background. My name is Steve Kumwenda. I'm working with Baseflow here in Malawi, but I'm also an independent consultant, a number of consulting services I'm engaged in with a different organization in Malawi as well as in the region, even with SADC-GMI. I'm going to just take off the video so that maybe it doesn't get a lot of my bandwidth for internet. Yeah, so presentation, or you gonna beam that side?
So Sechaba will share the presentation. Sechaba, kindly share the presentation.
Right, yeah, I'm just sharing it now.
All right. Thank you so much. Yeah, today I would like to share this borehole forensics work that we are engaged in. We've been conducting here in Malawi, and it's something which I feel is valuable to the young professionals in a sense that I'll talk more later towards the end, that understanding the borehole itself is the heart of groundwater. So that's where you need to understand the concepts, the fundamentals, and everything else. Next slide. Yes, so a bit of Baseflow. It's a relatively young local NGO with the social entrepreneur companies. We have Baseflow services, under which we provide services of borehole forensics, as well as we have a Baseflow construction for construction work of water supply infrastructure. Initially, we have been focusing mostly on infrastructure functionality, doing water points mapping, supporting the government to have a database, a nationwide database athlete for functionality of water points in the country. But Now our strategy is driving more towards water resources management. We're looking at catchments, watersheds, and yeah, I've put a picture where I was taken of an artesian well. I believe you know what an artesian well is. Water comes out on its own pressure from the ground. There are quite a number of wells across Malawi, and this is recognized as a waste because we are not managing the water. The water is just flowing. Even if they use for irrigation or other domestic uses, but there are points where it's not being used, it's just being wasted. So we have a passion that we remedy artesian wells as part of water resources management. Next slide, please. What is borehole forensics? Basically, it's something which maybe some of you are already doing, but it's simply a methodological way, a step-by-step process where you want to investigate what are the issues, all right? So the idea is to have data or to identify issues. The results should inform the decisions, what are going to help you with as a manager, or as well as anybody who is using boreholes. It really helps in trying to understand what are the issues in terms of operations and maintenance. And that aspect is that we emphasize mostly on collection of data. That means there has to be a way of trying to use management information system that is going to store that data over time. We should have time series data, and we're using mWater to actually store or keep our data. And since 2015, thereabout, we still have the data that we've been conducting borehole forensics across the country. In the map there, you see those dots are simply water pumping tests data that we have collected that is in mWater. And the red ones just indicate the failure of a borehole to pass a pumping test. Also, those blue ones, it means they really passed as per hand pump standard of 0.25 liters per second. We look at the importance of at least this can contribute to improve the sustainability of water point functionality, as well as on operations, as well as on installations. As we have investigated in some research, it shows that at every point there is a 30% borehole failure rate. So this includes boreholes that have just been recently installed. You find that at every point in time, 30% of the boreholes are not working, and that's quite alarming. Next slide, please. So in these steps or methods, first of all, you need to engage with the community, introduce yourselves, look at what they can do. They should participate, they should feel part of it, and also take a look at their hand pump. If it's an AfriDev, check the condition of functionality, ask about the years it has been in operation, the depth and so forth. This is simply to let the community reveal more information that you may need from their institutional memory. Next slide, please. Yeah, so you also have time to do on-site water quality tests before you engage in anything of dismantling the pump and so forth. So you have to do a yield test of the borehole to check how long the pump itself is taking to fill a 20-liter bucket, so that you can determine if it's efficiency in terms of pumping. You can do on-site quality water quality testing, like conductivity tests, TDS, pH, temperature, yeah, so that you are able to understand what the quality of water is before you disturb any status as you start now working on the borehole. Next slide, please. And then you definitely start the physical part of dismantling the pump. You actually start with the handles and all other casings, removing the rods, the rising main pipes. If the borehole has been opened, then you go to the next activity. Next slide, please. You need to check the water level. So you should have a deeper for you so that you can actually measure the water level, the static water level, which is very important. Yeah, you can use the units or references meters below ground level. And also, you should check the depth of the borehole using your dipper as well. Sometimes in most of the boreholes, they would have indicated the depth, but maybe due to siltation or other collapsing that may happen, it may change. So just to take the water level reading is very important as well. Next slide, please. Then you need to look at the design of the borehole. You would appreciate if you have an interest in boreholes, reports, drilling reports. It's very difficult. You would hardly find reports being kept, even at institutions where you would think they should have reports. I'll give an example here. We have the National Water Resources Authority, who are mandated to get every drilling report of a borehole that has been drilled anywhere else in Malawi. But they do have challenges to have these reports. Recently, we had submitted some of the drilling reports which we have supervised, the boreholes that we have supervised over the recent years, and they appreciated that. That's quite something, the beginning for them to build on, to actually be chasing for drilling reports and being able to file and keep them. So in absence of a drilling report, you wouldn't be able to know the profile of the borehole inside. You wouldn't know where the slots, where the joints are, or even some of the issues that have cropped up inside the borehole. So a borehole camera is an essential tool to be able to let you down into the hole to see what is there. So we do use cameras that are designed to be submerged in water. Yeah, so we're interested to check the casing type, the quality. Some drillers can fool you that they have used the best required standard material, but when you check with the camera, it's to the contrary. They can actually maybe indicate they have actually constructed the borehole according to this design. I'll show you later on, but it may not be the same. So the borehole camera survey is quite critical in terms of understanding the designs. And even if when you want to know more about how the aquifers, where they position the slots and where the aquifers were targeted, this is also very helpful. Next slide, please. Those are some of the pictures we capture during the borehole design survey. You can see some of the joints not done properly, but also some of the wells, they are actually living things, small living things like lizards in them. These are boreholes that were being used for drinking water by communities, but they were having these kinds of things. So really, it was important that we did remedy these. We recommended for blowing and treating the water. The two pictures below were actually videos which, if it was in a PowerPoint, I would have actually played them, but we'll see if we may have chance. Next slide, please. Yeah, so this is a scenario where we investigated one borehole and we compared with the report that was given. So these two profiles are for two boreholes. The one on the left is actually as it has been reported, whilst our camera survey on the right, that's what was observed. So you could see that in the report, it was indicated that there are screens around from 10 to 18 meters, and as well as from 25 to 28 meters. But when we checked with our camera, literally what we saw was the slots started from around 17 to 26. That's how this borehole was. And the depth, actually, with an end cap that was observed, it was 28 meters and not 35. So this was kind of like to check accountability, how drillers sometimes can operate and give you reports. So yeah, this was very vital to know this information. So if any service provider would want how their borehole looks like against what they were reported on, a borehole camera could reveal that. Next slide, please. Yeah, there is also another aspect where you need to check the straightness of the borehole. Some boreholes can actually deviate with quite a distance. There's an allowable distance in meters that it can deviate, possibly 1 meter from the center, or I'm not sure about that standard, but there is an allowance that you can deviate the borehole. But some boreholes can actually deviate even further to the extent that it may be around two meters from where it started, especially when you have very, very deep boreholes. This happens if the drilling is not being observed in the process, where maybe the leveling of the rig was not observed correctly, and also when the rigs were when the rods were being driven into the drilling, were not being checked if they're being put at correct position, straight position. So a deviation too helps actually to determine that the borehole is not straight beyond that it is allowed. And this can cause a lot of challenges. If the borehole is not vertical, the parts, especially for hand pumps, it kind of wear out fast, and this becomes a huge problem to the community in terms of maintenance and repair. So from that aspect, we find that some of the boreholes really need to have been checked for hand pump. Otherwise, they give a lot of problems to community in terms of straightness. The deviation too, however, is something that we currently not having, but the ministry, no, the National Water Resources Authority are the ones who are in custody of it. But other tools can also be available. I think inclinators could serve the same purpose. Next slide, please. Yeah, so that's just a pictorial focus of how the investigation was done, and it showed that there was that deviation of the hole from the center as it was. So this was discovered. Unfortunately, there's no remedy once you have found this. All right. So the remedy for this is during the drillings time, so that you are checking if the drilling is really done vertically and according to standards. Next slide, please. Yeah, then after you check the borehole straightness, you get into pumping test, and most of you, I know you're familiar with the pumping test. It's a very important exercise to check the yield of the well, the sustainable yield of the well. So yeah, we engage in step tests. You could have 4 step tests to determine your rate, which you could use for constant rate testing. Yeah, so the key thing is to check the borehole if it can supply enough water. For most of the boreholes, which are hand pumped, you don't need a lot of yield. For Malawi, as I said, it's 0.25 liters per second. And quite a number of boreholes do pass this, but we also observe that a number of boreholes do fail, mostly resulting from poor siting of boreholes. That contributes to that. And yeah, we do test these boreholes for a period of 4 hours for an after-dev hand pump, but we also engaged in long hours pumping tests, especially for high yield solar powered boreholes, there we could have possibly 24 hours pumping test with the observation of recovery that should inform the irrigated system if they can really stand with that yield that is being found. So pumping test data is also, next slide, please. Maybe there is something on analyzing. Yeah. So the pumping test data is very critical, as you might aware, for any hydrogeologist. This is where you get information on hydraulic conductivity, transmissivity calculations, relativity, sustainable yield. So most of this data, I know that maybe we might not get it from somebody who did pumping tests. It's very important that you get the correct information. Otherwise, I've seen that most of the pumping test data that has been done by someone else, I find there are a lot of shortfalls and challenges. So it's really, I think SADC-GMI at some point there have been courses to help build capacity in conducting pumping tests as well as analyzing data. I think I attended one of these courses. It's really important that we get the correct understanding of how to conduct pumping test in a very standard manner, because the data that is used has very huge implications in terms of the parameters that we need to understand. As I've said, hydraulic conductivity, pumping test, these are the determinants of aquifer characteristics. Next slide, please. So yeah, during pumping tests, there is need to still conduct the chemistry, checking the on-site water quality, that is salinity, TDS, and temperature. Also, you should be checking the flow rate using the bucket or a flow meter. Next slide, please. Yeah, another aspect is that since you dismantled the pump, you need to check the level of condition of how the parts are. So there is a grading system which has been developed that you should be indicating what condition the pump parts are. So the grading starts from 0 to 5, where if it's 0, it means it's missing, all right? But when it starts to 1, it means that's like it's very good condition, it's new, okay? 2, it means it's very, expected to wear, but it's in good condition, all right? 3, it means moderately, there is significant wear. It means it has served for quite some time, and yeah, it's wearing out. 4, it means it's a level of wear anytime it will break, okay? 5, it means it's broken. You don't actually have to use the rod, or you don't have to use the centralizers and all other parts. So this helps in terms of reporting which parts would need to be replaced. So from like 3 to 5, these are parts that you may recommend for replacement, for repairing. Whilst from 2, if a pump part scores 2, it means it's still in good condition, that it can operate for some time. So this is the assessing part of the hand pump parts, which really becomes very critical when you want to repair a borehole and targeting which parts need to. Next slide, please. Yeah, I've just talked of the methodology, but what are some of the key findings that I may share, especially with what we have seen in the field? There are issues of low yielding of boreholes against the required rate, which some may argue that a low yield borehole cannot result because of poor borehole construction standard or siting. A borehole could have been identified as high yield, but over time, maybe due to high obstruction, other factors could also end up in terms of becoming low yield. But we have seen that also poor siting of boreholes results into low yield as well. Some of the parts we have seen not according to standards, like you can see the casing here, that blue pipe casing for borehole. It's supposed to be milled at the factory with the standard required for slots that are supposed to let water in. But these guys just simply took a hacksaw and cut the pipe to improvise on slots. So that has a lot of implications on the type of water you're letting into the borehole with impurities and so forth. Some of the issues we observed is rusting due to high salinity, corrosion of pump pads and so forth. So all these are some of the things that we observe. And on top of that, some boreholes, as I said, the issue of straightness, perpendicularness of the borehole, it brings a lot of problems to communities, but it's something that cannot be remedied. Okay, but we can inform now the importance of following standards of drilling so that we have boreholes that are straight, that should not give problems to the community. We can inform policies in terms of siting, or even make programs of building capacity of geophysical explorations and siting and so forth. So the findings really aim at making a contribution in terms of remedies, as well as enforcing standards or policies for the future. Next slide, please. Yeah, again, there are quite a number of low-yielding boreholes below national standards that were commissioned. I talked about that. And also the straightness of the borehole. This is just the data that we have had over the years. Next slide, please. Yeah, finally, I want to just explain on how this could be of useful to young professionals. For me, I've seen that this is the work which actually you can start from in terms of understanding hydrogeology. It's the best practical learning point in terms of groundwater, okay? Because both aquifer characteristics as well as infrastructure understanding for groundwater, I think, starts from a borehole. All right, there are boreholes that are of high yields that are supplying huge cities, but still we need to get to understand to the bottom, to the source. So really, for young professionals, if you come across a borehole somewhere in the communities, get to know. Maybe sometimes there could be programs to renovate, to service. Be interested to understand what happens there. The fundamentals, I think, yeah, myself, I got them from a borehole. These days, we can have experts in groundwater by simply studying on the computer, on the desktop, okay? But for me, I feel that it's still important to go to the basics and have a feel of how you can measure the yield, you can measure you can have conducting the pumping test and get all the figures to manually calculate the aquifer parameters. All right. Again, if you're into borehole forensics, you can be an entrepreneur in terms of analyzing infrastructure as well as providing services for different organizations. Next slide, I think, should be my last one. Yeah, thank you so much. I believe I've not taken up much of the time. I tried to simplify and also to simply condense the information. I would indicate that if you want more information, we have some of the videos from Best Flow YouTube. You can check us, Best Flow videos. There should be videos which we have done on pumping tests and the borehole forensics that are there for your more information. Also, just to mention that this work actually is being positioned that we can document, so that there is a methodological, I would say, guiding manual that can let you do this whilst you're in South Africa, whilst you're somewhere else. You just use the manual to be able to follow the forensics processes. This is being done with a team which we call Stop the Rot. We're looking at how we can document this process that can be used anywhere else. Otherwise, thank you so much for your attention.
Thank you very much, Steve, for a detailed presentation. It's always exciting to see pictures in the field, and also fascinating to see how technology has advanced, especially when it comes to borehole cameras and how to better survey our boreholes. Thank you very much, Steve. That was really a good presentation, very detailed. And I believe all the hydrogeologists in the house, in the room, were just very excited to see every single slide, especially with the pictures in the field. It's just so beautiful to see. Thank you very much, Steve.
I made sure that I include pictures of young professionals.
Well,
yeah.
really,
and I've seen one of ours just right here, Gloria Mariana. She's one of the young professionals at Baseflow doing forensics.
All right,
yeah.
All right. It's amazing to see that. Thank you very much. I'd like to just give a quick reminder, young professionals, to please fill in the registration. I think that, Ashley, can you kindly share the link again in the chat? So please register. Up next, we are going to invite Silas, a young professional, to give us his presentation, evaluation of interpolation methods for mapping potential hydrogen for Windhoek municipal boreholes. Silas, over to you.
Hi, Gary, how are you? Can everyone hear me?
I'm very well, thank you. Yes, we can hear you. And thank you, Sachaba. We can see the presentation. Go ahead, Silas.
Okay, just hold on. I think my PC it's freezing a little bit. The network is bad.
We are displaying, the presentation is displayed, so you can just notify Sachaba whenever you are ready for the next slide.
Okay. So a very good afternoon to everyone. So basically, this presentation is gonna be short, very short due to the time that we have. So today I'm gonna talk about the evaluation of interpolation methods for mapping the potential hydrogen for Windhoek municipal boreholes. Next. So what we're going to talk today, we're going to go through the introduction, the study area, the materials and methods that was used for this study, the prediction methods that was selected, and then we're going to go through the results and discussion and also the conclusion. Next slide. So what we need to know is that water is actually life, as people say. and the quality of water determines the welfare of human being. So let's say if the water is polluted, then that means that the welfare of people are affected. But however, if the quality of the water is good, then the welfare of people are in good conditions. So basically, the determination of the quality of the public health depends on the quality of groundwater. Let's say if the what groundwater is contaminated by contaminants, then that means that the public health will be overcrowded, and it's always very important to ensure that the water quality are in good conditions before the human consume it. So basically, to instigate the concentration of the pH at uncertain measured location, we used the geostatistical technique whereby we go with the interpolation to say birds of the same feather flock together. So basically here the geostatistical was used because the earth have a special continuity. Next slide. So basically, this is a study area whereby it was conducted in Namibia, which is now in Windhoek, and you can see that that's the black dot is Windhoek, and then the gray area is the boundary of Namibia. So if you can see there on the top there, you can see the blue dots, whereby that stipulates the boreholes that was evaluated in the Windhoek, and it was about 110 which selected boreholes with different pH values that was measured. Next slide. So basically the methods and the materials. So we need, it was very important to ensure that we explore our borehole data. So by doing so, we went to the normal QQ plot to see is there any abnormal outliers within this data, and also using the histogram, whereby if there is a smooth curve, then that means our data are in good order in terms of the geostatistical analysis. As you can see here in the histogram, one can really see a curve, but not really that of a good curve. But the problem that comes with here is that, let's say if you delete some data from the 110 data of the boreholes, then it also ensures that whereby the data are also affected, and also whereby your prediction will also be affected. So in this case, I decided, like, no, I'm just gonna leave the histograph the way it is, even though it was not really of a good curve. And then we went to the trend analysis, and also for the semi-variogram to see, exploring our data to see if the data really having any other abnormalities or outliers that we need to cut down. But however, in this study, there was no any other outliers that was cut out. So we just left it as it is, just to ensure that this doesn't have an impact on the later stage when we do the geostatistical analysis. Next slide. Next slide, please. Okay. Okay, so basically there were different types of geostatistical method that was used for this study. The main one was the core kriging, the empirical Bayern kriging, whereby in these two types of the geostatistical method, where they were used to differentiate or to do a comparison in terms of the value of the mean square root, the root mean error, the standard deviations, whereby they were tested to ensure that, okay, which one has a better, less error, or which one gives a more accurate prediction in terms of the pH evaluation. Next slide. So as we can see here, we have the two methods that was used, the co-kriging and then the empirical Bayesian kriging. So as you can see there with the co-kriging, we actually have good value in terms of the errors of the prediction. And then if you look at the empirical Bayesian kriging, you get, let's say the mean standard is negative and then the mean is negative. So which means that that's not really of a good error to use that method. So in this case, co-kriging was was the one that was used to do the prediction and also the analysis and the mapping for the prediction of the boreholes by at the unmeasured locations. Next. So as you can see here, this is now the co-kriging interpolation method, whereby it has different types of values, whereby the red one has a pH of from 7, and then it can it predicts how far that can go, whereby where else you potentially can get a pH value of 7. The same applies to 6.98 pH, whereby that gives a prediction of where in at an unmeasured area, or let's say at undrilled areas, that you can find such pH values. Next slide. So basically, what we conclude is that co-kriging is considered as the adventurous, the best method to do the evaluation and also to do the management of groundwater. Let's say it also cut cost. Let's say if you go in the field and then you collect data or drilling data of boreholes. With geostatistics, you can actually do a good management of groundwater resources to say, okay, at this unmeasured area, you can find such potential, and how can you try and manage the water quality instead of one going in the field to do the whole analysis again and so forth. So basically, this is a good method whereby it can cut cost into the operations, and also it gives a better decision-making processes in terms of the groundwater management. So basically, this comes to the end of the presentation. So if you have any questions, you can reach out to my email address, and then maybe we can discuss that. So I would also like to thank the Ministry of Mines of Energy of Namibia for this study, and also for the YES Network of Namibia, and also for the International Union of Geological Sciences for assisting me also with this project. Thank you.
Thank you